Okay, in this video I go over my logistic regression problem. I did it slightly different when I did the analysis on this side. We'll talk about that in a minute. But the first thing is that you had to clean the data a little bit. You had to have some dummy variables, if people lived alone or gender, and these were a bunch of zeros and ones because there were only two choices. But when we have three choices, like dwell type, we had condo, home, and apartment. We need to have two levels, two different dummy variables. One of those represent one of those levels, and then when you have a null like that one, that means that it's the third choice. So I have a dummy variable representing home, so anytime you see a 1, that means they lived in a home. I also have one for condo. So if you were to get a null or a 0, 0, that means they were in an apartment. You had to do the same thing with neighborhood. Neighborhood, I had one for east and west, so the south, like that, that was the person in the south. So when you have three levels, you have to have two dummy variables. Once we did that, we also had to scale the data, and if you can see what I did is I used income and I scaled it by dividing by 1,000. I took car value and car debt and divided by, I think, 100. So that if I looked at any of these numbers in here, of all of these numbers, the biggest value is still in the hundreds. I don't have anything in the tens of thousands like I had before, and that really helps a solver when it's trying to solve problems. Two large numbers combined with small numbers is makes it hard to do things. So it does work when you scale it this way. And after I did that, then I set all these equal to 0. Copy, paste special, and then when I hit solver, which is already set up, it was just, I'm only changing the first one, and I'm using the nonlinear solver. And when you solve this, you get a maximum likelihood of minus 582 is what I got with the intercept. It tells me if I got it correct or not based on a plus or above 50%, and I can get a percent correct and my log likelihood. So what I did is that I just I added a variable every time. So I added age, and then age and weight, and then age, weight, income, and obviously the order that you add them influences if the model is getting better or not. And so the order, it would be ideal if you would put in the most important ones first. Well, you don't know that, so it's kind of hard to think about it that way. But the way this analysis that I did was looking at incrementally or stepwise adding variables. And that certainly influences which ones are important. The other thing that I did that was different is I compared, when I did the delta, I didn't do delta against the intercept. I did the delta from the previous model. So if I look at this one, it's the difference between these two. Intercept and then adding the variable. But when I did any of these other ones, it's always just looking at the one above it. I didn't compare this one to the intercept. It was always looking at how is this model relative to the one above it, which means the degrees of freedom are always just one more, because I'm going from, in this case, one variable to two variables, so there's only one more degree of freedom that we did. And as opposed to what we did in the lecture, that when we compared this one to this one, then I would have 3 degrees of freedom because I've had 3 variables in it. And I know that's confusing, and I didn't go over that, but that's what I did on this analysis. So when I'm looking at these, I'm looking at any of these, looking at the one to right above it. I'm comparing this model to this model. So when I do that, I can look at percent corrects, which they're really good estimates. They're probably not the best from a statistical standpoint. The best thing to look at are the p-values of comparing the difference in these log likelihoods from model to model. So when you see a big jump like this, see these big jumps, that means there's definitely some an important improvement. If you see small jumps like this, it's probably not much of an improvement. So once you've done and you look at the p-values based on these jumps, all we're looking for is that when we have a small p-value, then it's a significant improvement. So all of these blue ones have small p-values. The ones that have large p-values, this one, and these are all bigger than 0.05, which tells me that these are probably not important factors in why people buy lasagna. So if I look at what was added in that time was car value. So the car value doesn't add value. Crazy, gender is not important. Gender didn't improve it. And then where you live. Do you live in a home or a condo or apartment? Did any add any value? So those four factors are not the drivers of did they try it. You could argue of the other ones which one's more important because again order makes a difference. But that's the analysis that I did. Thanks.